Look up here. So this is, number 3 is a special kind of double replacement. So if you were swapping places and you saw hydrogen out front, how does hydrogen react? It reacts like a metal, right? It's on the left-hand side of the periodic table, so it reacts like a metal. What would it replace then? Sodium or hydroxide? It's going to replace sodium because metals replace metals, right? From single replacement. So it's going to replace sodium. If it replaces sodium, look what you're doing. You're adding a hydrogen to an OH. What would you get?
H2O.
H2O, very nice. You get water. You get water.
I feel like such a
Right? So if you get water when you add H to OH, what's the phase of water? Can I say it's aqueous? No, because aqueous means dissolved in water. So what's the phase of water? It's just liquid, right? So it's an L. You see this phase change? You went from aqueous and aqueous to liquid. So is this reaction going to happen? Yes, right? If you get a phase change, the double replacement happens, right? It actually occurs. What's the other product other than water? Sodium sulfate. Sulfate is a 2- ion, so how many sodiums do you need? You need 2 of them. All right, so that's, what about sulfates? Are sulfates soluble in general? They are soluble, and especially anything with a group 1 element like sodium is going to be soluble. So this is going to be aqueous. That's the phase on this one, aqueous. All right, but there was a phase change. We went from aqueous to liquid in aqueous. So this reaction does happen. This is called a neutralization reaction. So it's a special kind of double replacement. The reason it's called neutralization is for a very simple reason. OH, that's base, right? It's the property of being a base, right? Having some OH. H plus, that's an acid. If you put acid and base together, you become neutral. They neutralize each other. You get something neutral. That's why it's called a neutralization reaction. Does that make sense? So it's a special kind of double replacement. All you need to know for our purposes is that if you combine H and OH, you get water. And that is a phase change. That's going to occur. You don't have to know this term, neutralization. You don't have to know that. And you don't have to know, well, no, you do have to know this, right? If the cation is hydrogen, you have to know that's an acid because you have to be able to name it. You guys know how to do it, right? What's the name of this acid? Is this a binary acid or is it a oxy acid? It's an oxy acid, right? Because it contains oxygen. So what do? We just take the name of the polyatomic ion and we add ic if it's an 8 ion, and we add us if it's an ike ion. So what is it? Sulfuric. Exactly, sulfuric acid. Nice. All right, keep working. I just want to give you a hint that this one is just like numbers. This is exactly like number 4, number 6, number 8, number 11. They're all very close to this example, okay?